This video is about solid of revolution, and here I have this yellow region right here, and I'm going to revolve it about the line y equal to 4, and we want to find the volume of the solid of revolution. And so here this is the region that is bounded above by the graph 2 times the square root of x plus 2, and is bounded below by the line y equal to 4, and from 1 to 9. And we're going to revolve this region right here about the line y equal to 4. So let's revolve it. And we have the solid of revolution. And to find the volume of this solid of revolution, what we would do is we would divide the solid into many slices like this. And then each slice would be a cylinder, and we would find the volume of each slice and then add the volumes of the slices together, and that will give us the an approximation for the volume of the solid of revolution. And this is one of the slices, and so let's call this the ith slice. And so let's go find the volume of this ith slice. And so the first thing I'm going to do is I'm going to divide the interval from 1 to 9 into n number of sub-intervals. So the first one here, let's call it x of 0, which is 1. And then we have x of 1, x of 2, x of 3, x of 4. And then eventually we'll get to the ith sub-interval. And this will be x of I minus 1, and this is x of I. And from this ith sub-interval, that's where this disk comes from. And then we get to 9, which is x of n. And so let's say that n is 8, and then we would have 8 sub-intervals. And the length of each sub-interval would be 1, because it's 9 minus 1 over 8, which is 1. If we let n be 80, meaning we want 80 sub-intervals, then the length of each sub-interval would be 0.1, since 9 minus 1 over 80 would be 0.1, and the thickness of each slice would also be 0.1. And so in general, the thickness of each slice would be 8 over n. And let's call the thickness of each slice, let's call it delta x. So once again, this is the ith slice, and it comes from this sub-interval right here. So right here, this would be x of I minus 1, and then right here, this would be x of I minus, this would be x of I. So x of I minus 1, and then x of I. And f of x of I, so x of I is about right here, and so f of x of I would be the distance from the x-axis up to the graph. But f of x of I is not the radius of the disk. The radius of the disk is just from here to here, from the axis of revolution up to the graph. But f of x of I is from the x-axis up to the graph. So to get the radius, what we would do is do f of x of I and then minus 4. So it would be the distance from here up to here and then minus 4. And so that would be the radius of the disk, of the ith disk. But f of x is 2 times the square root of x plus 2. And so f of x, the radius of the disk would be 2 times the square root of x of I plus 2 minus 4. And we end up with 2 times the square root of x of I minus 2. So the volume of this ith disk would be pi times the radius squared times the height. The radius of the ith disk is 2 times the square root of x sub I minus 2. The height of the disk is the thickness of the disk, which is delta x. So this would be the volume of the ith disk. If we divide the solid of revolution into n number of slices, then the volumes of n slices would look like this. This would be the volume of the first slice, volume of the second slice, and then volume of the nth slice. Using summation notation, then we would have the sum with the expression pi times 2 times the square root of x sub I minus 2 squared times delta x. Once again, this is the thickness of the each slice, and then this is the radius of the ith slice. And 2 times the square root of x sub I minus 2 squared is 4 times x sub I minus 8 times the square root of x sub I, and then plus 4. So this right here, this sum is the volumes of n slices. And therefore the volume of the solid of revolution will be approximately this sum right here, which is the sum of volumes of n slices, which is just an approximation. So if we want the exact volume, then we need to divide the solid into an infinite number of slices. And so we would let n run to infinity, and then we would write it like this. It would be the limit of this sum right here as n approaches infinity. And if this limit here exists, then we defined it as the definite integral from 1 to 9. 1 to 9. And then here's the pi, and then 4x minus the square root of x plus 4, and then times dx. The integral of x is just x squared over 2. This is the square root of x, which is x to the 1/2. And so to integrate, we add 1 to the exponent 1/2. 1/2 plus 1 is 3/2. And so we get x to the 3/2 dividing by 3/2. And the integral of 4 is just 4x. And then simplify, we get 2x squared minus 16x to the 3/2 over 3 plus 4x. Evaluating from 1 to 9, so when x is 9, we'll get 162 minus 144 plus 36. When x is 1, we get 2 minus 16/3 plus 4. Simplify everything, we get 160 pi over 3. So the volume of the solid of revolution is 160 pi over 3. And that's the end of the video.